All right, my friends, welcome back. Today's instructional objective. Students will be able to identify the different kinds of weathering and factors that lead to landscape change. Do now says, draw the illustration listed in the boxes below. So I'd like you to take a moment and to draw a dendritic drainage pattern, and then try and draw a radial drainage pattern. You're going to be using your notes from yesterday to know what those things look like. Today's mini lesson, we have an introduction to weathering events, about 15 minutes worth of notes. Quite a few things that are going to be on this, but luckily you have a full copy of these notes that you can use to review. Today's activity, we have a weathering types ed puzzle. It's a 7-minute long video, and you have multiple questions in there you need to answer. All right, so let's take a look at what you guys came up with. Definitely a radial pattern on the right, dendritic on the left, radial on the right. Beautiful. Okay, that's a bit of a stretch with that dendritic, but good, good. Okay. Well, some people are more artists than other. All right, so let's jump right in. So this is kind of a bit of review and new material. And again, you have a copy of this. It's on the Google Classroom on the first page. So today, weathering. Weathering is the process by which rock breaks down. It's caused by exposure to the hydrosphere and the atmosphere. So those two terms should sound familiar. In fact, if anything, let me share my screen. You should remember them from ESRT page 1. So when you talk about the composition of materials, and especially like the elemental composition of the Earth, when you look at the crust, well, we know what the crust is. It's the surface. Hydrosphere is actually the oceans. Hydro contains like hydrogen, as in water. And in fact, if you think about it, water, the formula for water is H2O, right? Well, look at the ratio here. You've got 2 parts of hydrogen, 1 part of oxygen, H2O. That's water. And then over here it says troposphere. Now we haven't gone over the layers of the atmosphere yet, but the troposphere is the bottommost layer. So yeah, that's what we're looking at. So yes, water and air. That's what causes weathering. Now there really are 2 specific types. We've got physical and chemical. You can tell here a lot of physical weathering has occurred. Now, how do I know this was physical weathering? Sharp, jagged edges. If there was chemicals being involved, think like acids, it would have probably melted those down and gave them more of a rounded edge. So physical weathering, force causing a change. Our first one is known as frost action. Sometimes we refer to this as ice wedging. Water is going to get into the cracks of the rocks. When it gets cold outside, that water will freeze, and as it freezes, it busts the rocks apart. Take a look at the specimen in the bottom right. I mean, this thing got destroyed. It's almost like someone took a saw and just kept cutting it up. That's the power of freezing water. So if you look on the left here, you can see water got in the crack, froze, busted apart. Same thing on the right. It's amazing how much pressure is behind it. Don't quote me on this, but it was something like 20,000 psi worth of pressure, if I remember correctly. Meaning, like, if you put water into a steel pipe and you seal both ends, in all likelihood, the ends are going to break off and that pipe's going to split down the middle. In areas where we have frequent freeze-thaw cycles, like in upstate New York or in Alaska, where it constantly drops between 20 degrees Fahrenheit and it goes up to maybe like 40 degrees Fahrenheit, you end up getting freezing, thawing, freezing, thawing. So every night the rocks break a little bit more. You ever wonder why we get potholes in January and we don't get potholes in the middle of the summer, where we get much fewer? It all comes down to that freeze-thaw cycle. Now, water alone isn't the only culprit. We also have things like plant action. So, plant action, Root wedging is where the roots of a plant are going to grow into the actual cracks in, let's say, for example, in this case, a boulder, and bust them apart. Again, the power of water, whether it's trapped in a root or not, is pretty immense. Yeah, these boulders were cut right in half. On your way to school, you see this. Tree lifted the sidewalk, cracked it, broke it in parts. And then kind of a more of a rare one is exfoliation. You probably heard the word exfoliation before for like, I don't know, face lotions or face washes. Exfoliate, they remove those dead layers of skin. Well, exfoliation also happens when you pressurize something and then you release that pressure. So, memory foam, right? If you got a piece of memory foam and you squeezed it down real tight and then you let it go, it would pop off. The top layer would pop off of it, and it would leave like the lower layer intact, and the top layer would just be sitting there. And that's what we're seeing in this case, especially with upstate New York, where we had miles thick chunks of ice sitting on top of it during the last ice age. When that ice melted away, the pressure released, we had a rebound. And really, our last for physical would be abrasion. So, abrasion is the process of rubbing rocks together. Generally speaking, we're talking about dry environments, but this can also happen in wet environments as well. This image you're looking at is an image of rocks on Mars taken by the Curiosity rover. So, what you're looking at is sand in an environment that has no water at all rubbing against each other, and it smooths off those edges. Now, this could also happen at the bottom of a riverbed. Quick check for understanding. Physical weathering is what? Okay, I'm still waiting on a few people. I only have 5 responses. All right, so believe it or not, the answer is B, a large object being broken down into smaller pieces. Whenever we talk about the atoms being broken down or changed, we're really referring to chemical weathering. And that brings us to chemical weathering. So one of the most common kinds that we see is known as oxidation. So oxidation is when oxygen reacts with that mineral or the elemental bonds within. Oxygen is very reactive. You ever see like on a package where it says like keep in a cool, dry place? Well, we want to keep the oxygen away. That's the primary thing. This is why a lot of our foods, when we open them up, you hear that hiss sound because they're being kept in a vacuum to keep the oxygen out. You could eat a bag of chips that are 6 months old as long as that bag has been sealed. But the minute you open that bag, it's like a timer goes off, and you got to eat them quick before they get all gross. And most of that is because of the oxygen reacting. Now, in nature, we typically see this oxidation appear as rust, and we really find 2 primary kinds. We find it as a red rust and a green rust. Red rust happens with iron oxides. Green rust happens with copper oxides. Now, it's not just rust that's a problem. It's also carbonic acid, also known as acid rain. So carbon dioxide in rainwater is going to create a weak acid. And that acid will then eat away at, in particular, limestone. So if we take a look at our Earth Science reference table and we go down to page 7, you'll see that limestone is made up of the precipitates of biological origin cemented shell fragments, which are made up of calcite. And if we go to ESRT page 16, we'll find that calcite is made of calcium carbonate, CaCO3, which can also be found in cement, which bubbles with acid. So what does all that mean? Acid can eat away at calcium carbonate, which is cement, and which is, we're getting there, limestone. Seems a little bit complicated, but if you think about it, this is where caves come from. It rained on this surface with acid rain. Acid rain seeped into the surface, dissolved the limestone, put the limestone into a liquid form, and then eventually exited out the sides. That's how caves are formed. It doesn't happen overnight. Acid rain can also be made by human processes, so burning of fossil fuels in particular. Anytime we release carbon dioxide into the atmosphere, whether you're burning coal or wood or even natural gas, some things are nicer for the environment than other, but there you go. Now, this also happens in a natural way, in particular with volcanic eruptions. When that happens, sulfur dioxide, hydrogen dioxide, carbon dioxide, and hydrogen fluoride, among other things, are released into the atmosphere. They combine with the moisture in the air and fall down as acid rain. And take a look at what happened to our poor friends here. These sculptures, I guarantee, did not come out looking this way. Look at this guy. He had a bad day. So these are the two effects that acid rain has on limestone or marble. But if you take a look at this pretty lady right here, so Statue of Liberty, Lady Liberty, she did not come to New York Harbor as a green person. She came as a brown person. She was completely copper. And within just a few years, the acid rain that was falling in New York City turned her from copper colored to green. Oxidation. So actually, we have two different things here. We have acidification and oxidation. So this is part of the Black Forest in Germany. Doesn't look very black anymore. Acid rain ended up killing many of these trees. See how it can kind of be an ecological nightmare. All right, next up, physical or chemical? What's going on here? I see a nail sticking out of a board, and it looks pretty darn rusty. Physical or chemical? I've only got 5 responses. Physical or chemical? 3, 2. Yeah, so this is a chemical reaction. It's oxidation. We're seeing it rust. What about this one? I see a plant sticking out of what appears to be a granite wall or some kind of igneous looking rock. Might be potassium feldspar. But either way, we got a plant growing in a crack. So what are we looking at? It's not frost action because there's no frost, it's no water. It's not oxidation because I don't see any rusting. It's got to be root wedging or root action. And this is physical. Very good. Okay, we got an exit slip here. Describe one kind of physical and one kind of chemical weathering that may alter this landscape. I see a concrete walkway. I see a bunch of trees. I've got water on the ground. Take a moment, try and answer that. While you're working on that, I do want to draw your attention to today's assignment. So today you are rated on your feedback on the Pear Deck, and we do have an Ed puzzle on weathering events. So what you're going to do is you'll go to classwork, you'll go to this week, we've got Ed puzzle here. You're going to click through on it. Oh, I gotta sign in. Okay, I'll do that later. But once you sign in, it's a 7-minute long video, and you have a few different multiple choice and open response questions on there. All in all, you should be able to complete that within about 15 minutes. If you did not finish the assignment from yesterday, stream drainage patterns, that is due by midnight tonight. All right, so I'm going to give you a couple minutes to wrap up work on what you're doing now. If you have any specific questions, I'm going to be hanging out here for the next 20 minutes. We will be having tutoring tomorrow from 3 until 4. And if you have any questions for me, I'm here. Have a good one, guys.